Hello everyone and welcome back to C Puzzles. We're going to continue on with operators 3.4 from the logic and increment operators section. For those of you that are following along, we are solving puzzles out of the C puzzle book by Alan R. Feuer. Feel free to go ahead and pause the video and try to solve operators 3.4 on your own before we jump back into the solution. Alright, here we go. Operators 3.4. Once again, we got the main snippet of code. We got our main function with the statement under question here being highlighted in teal/cyan. We got z plus equals minus x plus 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 y, followed by two print macro invocation calls with x and z being passed in as the identifiers. Now before we go ahead and begin solving operators 3.4, let's talk about compound assignments for a little bit. Compound assignments in C/C++ are a shorthand notation to take the original L value and perform some operation and assign the result of said operation back to the L value. What does this mean? Well, here we have four examples. Here we have the additional, subtraction, multiplicative, and divisional compound assignments. In the middle column, we have a sample code of how one might see this in a statement. And on the right-hand column, we have what will be the equivalent of that statement. Starting from the additional, we have plus equals. Sample code here, we can see we might see as x plus equals 1. And then the equivalent code of that being x is equal to x plus 1. And going back to our definition, what we will be doing is taking the original L value, in this case the L value being x, perform some operation, the operation here being adding 1, so x plus 1, and last but not least, assigning the result of x plus 1 back to the L value being x. Following the same suit, we have minus equals, x minus equals 1, so in this case we will be subtracting 1 from the value of x, and that result will be assigned back to the variable x. In the fourth row, we have the star or asterisk equals, sample code here being y is equal to star or y star equals x plus 5, the equivalent being y equals y star x plus 5. In this case, we'll be evaluating x plus 5 first. Once that has been evaluated, that will then be multiplied by the value of y, and then that multiplicative result will be assigned to the value of y. And last but not least, we have / equals, sample code here, z / equals plus plus x, and the equivalent code would be z is equal to z / plus plus x. In this case, we'll go ahead and increment x first, given the prefix increment operator. That result will then be the denominator of z divided by that value, and then the result of that division will be assigned back to the variable x. Alright, operators 3.4. So once again, we got the line of code z plus equals minus x plus 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 y, followed by two print macro calls here. So in the above statement, we have 5 operators. We got the compound assignment, we have the unary minus, the postfix increment, which follows the x, the prefix increment, which is before the y, and the addition, which is in between those two. So of these operators / operands, which do we evaluate first? The one with the highest precedence. In this case, it will be the postfix increment, although it's not super clear here just by looking at the statement, so we'll have to go ahead and revisit our table here. We can see from the very first top row of the table, we've hit the postfix increment, taking the highest precedence, and we note that we do have one of these operators in our statement. Jumping to the second row, we have the prefix increment, and we have the unary minus, so we have 2 of these, and the associativity would be going from right to left in this case. Going down the row, we have addition, which we see in our statement, with the associativity being from left to right. And jumping all the way down to the very last row, we got the addition assignment. The compound addition assignment here has the lowest precedence of all the operators above, with its associativity still being right to left. So going back to our code here, we see we have one postfix increment, which is the one that trails the x. And what we'll go ahead and do is we're going to go ahead and munch off as much tokens as we can in order to find out which operator we have. In this case, we got the value of x. We have a white space here. We'll ignore that white space here, the blank space. And then we got two plus plus addition signs. And so the compiler will go ahead and bind those two plus plus to x. And we'll make note that this is considered a postfix increment. Once that has been established, we can go ahead and enclose the x plus plus in parentheses. Once this has been done, we can see now that the next operator that has the highest precedence following the postfix would be between the prefix and the unary minus. But note that we're going from right to left, in this case, from their associativity in the table, starting from the semicolon, going from right to left. Once again, we'll ignore the white space that sits in front of the y. We'll see we have two plus plus signs, and we'll go ahead and bind those to the value of x, noting that this is the prefix increment operator. So once here we have the same concept that we applied with x, we can go ahead and enclose that, and we can go ahead and close the prefix increment with y in parentheses. Still going from left to right, we can see that we have an addition. Continuing going on, we have the enclosement of the postfix of x, which we did in the previous step. And we can see here we have a unary minus. We'll go ahead and bind that to the enclosement of x plus plus, given that there's a white space there. And last but not least, we can see that the whole statement above actually comes down to an addition of the postfix increment x that gets negated first, and the addition of the prefix of y, replacing the values of x and y with their respective values from the previous examples. X has a value of 2, so replacing x with 2, replacing y with a value of 1, and so forth. Now before we go ahead and begin to solve this addition, which has the next precedence after resolving the post/prefix and unary bindings, we'll go ahead and increment the value of y, in this case a value of 1, since we must perform this execution before we actually perform the addition. So therefore y will become a value of from 1 to 2. We increment that. And then we have the statement here, y or z plus equals minus 2 plus plus parentheses, and then plus 2. Once again, we'll go ahead and negate the value of 2, given that that's going to go ahead and be performed, given that after that value, we'll go ahead and postfix the value of 2 to 3 after we perform this negation here. So we have negative 2 plus 2, which results in 0, making note that we will have to increment 2 to a value of 3 for the postfix increment execution that performs after the addition. Nonetheless, the result of negative 2 plus 2 is 0, and now we can perform the compound assignment operator, z plus equals 0, which is equivalent to saying z is equal to z plus 0. And last but not least, the value replacing z with the value of 0 from the previous examples, we have z is equal to 0. Once again, we assign this value back to 0, so we don't do anything here. And last but not least, we have two print macro invocation calls, which are the equivalent of calling the standard input-output printf functions. The first one would be passing the identifier x, noting that x was the value was 3. In this case, we have 3 here. So calling printf with decimal format specifier of x, we'll go ahead and see a value of 3. The next print macro, we'll go ahead and pass in the identifier z. Note from the previous example, or in this case from this line, z is equal to 0, so that has not changed. Go ahead and calling the printf standard IO function with z being passed in, z being 0, we should see a value of 0. Jumping to our code here, see here we have uncommented operator 3.4. So the last two values that get printed out to the terminal will be the values of z and x respectively. Going to go ahead and compile the code here and then execute the executable. We can see here once again we have value of 0 and 3, which is the values that we had noted for z and x, so 0 and 3. Alright, thank you all for watching. To watch the previous puzzle, click on the bottom left corner, and to subscribe for more C programming puzzle content, click on the bottom right corner.